Hello, my name is Parmida Heydari, and today we are going to learn Kubernetes introduction. Kubernetes is kind of orchestrator tools which provide wide features for us.
Like scaling, it can automatically scale applications up or down based on our demand. Load balancing. Kubernetes distributes network traffic to ensure that no single instance is overwhelmed. Also self-healing. If a container fails, Kubernetes automatically replace it with a new instance. Resource management. It manages resources across a cluster, ensuring that each application has the necessary CPU and memory. Let's take a look at Kubernetes components. A Kubernetes cluster consists of a control plane and one or more worker nodes. Here we have only a control plane and 3 worker nodes. A control plane manages the overall state of a cluster, and it consists of a kube API server which exposes the Kubernetes HTTP API, etcd which is key value store for all API server data, kube scheduler assign each pod to a suitable node, Kube Controller Manager runs controllers to implement Kubernetes API behavior, node components providing the Kubernetes runtime environment, and it consists of a kubelet which ensures that pods are running, kube proxy maintains network rules, container runtime for running a container. Notice that using an odd number of master nodes in Kubernetes is a best practice that reduces the risk of split brain scenarios. Let's learn what is Kubernetes namespace. Kubernetes namespace are a way to divide a single cluster into multiple virtual environments, and it provides isolation. Each namespace acts as a separate environment, ensuring that resources in one namespace do not interfere with those in another. Resource management. Namespaces allow administrators allocate resources and set quotas for different teams and projects. Now it's time to set up our first cluster by Minikube. Visit minikube.6.k8s.io, choose your operating system, architecture, and installer type, then install Minikube, and by running Minikube start, you can start your cluster. Make sure you have kubectl on your system to interact with your cluster. Actually, I have installed Minikube before. By running Minikube start, you can start your cluster. I have done that before. By running kubectl get ns, you can take a look at your namespaces. And by running kubectl get nodes, you can take a look at your nodes. Now let's learn what pod is. Pods are the smallest unit of computing that you can create and manage in Kubernetes. Pods in Kubernetes are used in 2 main ways: pods that run a single container, pods that run multiple containers. Here is a simple pod YML file. In Kubernetes, we write YML file for our objects, and it is short form of Yent markup language and more simple to write. I have this file here, which run nginx pod. By running kubectl apply, you can create your pod, and by running kubectl get pods, you can take a look at your pods. Here there is nginx in default namespace, and there are some other pods in kubesystem namespace. Usually we don't need to create pods directly. Instead, we create another workload resources, such as deployment, a stateful set, daemon set, or jobs. Let's create a job. Here there is a simple job which print hello and sleep for 60 seconds. By running kubectl apply, you can create your job and you can see that there is a pod which name hello, and also there is a job which is not finished yet. And if the job finish, this pod will disappear. Pods are ephemeral, and if they fails or if their execution finish, they will be disappear. That's why we use another workload resources such as deployment, stateful set, and daemon set. We will learn about them later. I hope you enjoyed this video.